I'll be discussing smart robots, and a particular area I would like to focus on is human-robot collaboration. This is Emerging Technologies under Professor Patrick Mack. Overview and background. A new generation of robots are redefining man-machine interaction and rewriting the way that automation can be used in manufacturing environments. Collaborative robots can perform a variety of repetitive assembly tasks, all while safely and intelligently working next to people without the need for traditional safety barriers. Since robots first started appearing in factories 50 years ago, they have operated autonomously. But recent safety standards and technological advancements have allowed engineers to implement friendly features that promise to improve productivity and increase the use of robots. Motivation for collaborative robots. Well, if you notice in this diagram here, you have the conventional industrial robots, which is separate players, safety by separation. You see no collaboration, no moving contact, and the robot produces according to application design, which creates limited flexibility and high cost. On this end of the spectrum is the emerging technology, the collaborative industrial robots, team players, harmless manipulators, full collaboration, contact okay. Human and robots share tasks according to respective strengths, which an outcome is higher flexibility and moderate cost. Where on the hype cycle? Where smart robots are under the innovation trigger, as you notice right here, I have it highlighted in red, outlined in red, excuse me. The plateau is about 5 to 10 years. The benefit rating is high, and the maturity has a couple emerging sample vendors that I will discuss, one in particular, as we continue on in this presentation. Risk. Conventional industrial robots work with high precision and speed, but only on a large scale. This makes them relatively expensive, inflexible, and dangerous for humans. Safety is key for collaborative robotics. It is often achieved through complex control systems, but robots, of course, are rarely designed to be inherently safe. Also, robots lack the sensitivity that humans have. The tactile sense is a human ability that comes in handy in a variety of production processes. Also, service robots needs to perfectly fit customers' needs, but solutions are often standardized. Finally, very often R&D in robotics remains at the research stage and does not reach the market. Customers find it difficult to become familiar with cutting-edge robotic technology. Cost. Traditionally, robots have not been a cost-effective option for small manufacturers. However, the reshoring trend has contributed to the demand for lower cost, safer, and more flexible automation technologies such as collaborative robots. Costs are coming down and robots are getting smarter with advanced capabilities. Manufacturers are moving back on shore and clamoring to automate. Well, what if you could employ a highly skilled laborer for 75 cents an hour that can work 24 hours a day, 7 days a week for 52 weeks a year without needing breaks? A no-brainer. Well, a single arm or dual arm, 6 axis or 7 axis, cost range about $25,000. Baxter, which I will talk about later on. Another aspect of cost I would like you to think of when we're dealing with robots here is think long term. It might not be that simple, but it's not rocket science either. It just takes a little effort. Robots are flexible, dynamic machines. The return on investment may be difficult to pin down, but not impossible. Rethink Robots Baxter is stacking up 10 months in return on investment already. You notice here I have a diagram that shows the robotic system cumulative cash flow over a 15-year span, and it goes from $0 up to about three $3.2 million, which is incredible. Market potential and positive societal impact, human-robot collaboration still represents a new frontier for both producers and adopters of this technology. On the other hand, a series of challenges need to be overcome, notably safety and risk aspects, financing of high-tech, market entry, commercialization, R&D, as well as talent attraction. 4 points I would like to bring up about the potential obstacles are skills and talents. Finding the right skills and recruiting talents is a typical challenge for young companies. Due to the unparalleled increase in knowledge in the field of robotics over the decade, universities are not always able to keep up with their curricula. As a result, recent graduates are lacking basic knowledge needed for jobs in service robotics. Yet another difficulty lies in the attraction of talents. Evidently, small companies and startups have a hard time in competing with the engineering giants such as GE that can offer more in terms of salary, job security, and prestige. Commitment to collaborative robotics. The first difficulty lies in convincing clients of the benefits of collaborative solutions. A second challenge is related to the acceptance of cobots by their fellow coworkers. Safety and risks, robot governance. The first Asimov law of robotics states that a robot may not injure a human being or through inaction allow a human being to come to harm. Guaranteeing safety, ladies and gentlemen, to workers represents one of the biggest challenges in human-robot collaboration. Finally, financing robots. Access to finance is one of the most common challenges for startups and SMEs. As pointed out by Fur Robotics, a robot startup needs to reinvest its profits in the early years in order to reach a critical size and expand globally. Many private equity and venture capital firms expect returns much earlier and are not ready to front such an investment. A second issue encountered is related to raising the second round of investment capital needed for the expansion of the sales and distribution network, as well as for additional product development. Opportunities that can be achieved. A collaborative robot can share a workspace with humans. Physical separation is not required. Now, with the change of sensor and robot control technology, a robot can reliably detect and adapt to intrusion into its work environment, meaning physical barriers are no longer essential for safe operation. More flexible manufacturing practices, such as this robot doesn't have to be dedicated to this same task throughout the year or throughout the day. And within minutes or hours, you can simply show the robot how to do something else for you. Save space and money. By this, with traditional robots, they took up a huge amount of space, and with that comes money. Testing and evaluation. Meet Baxter. He is a 2 7-axis arms connected to a torso and sports an LCD display for a face that reacts to human interaction. He weighs in at about 75 kilograms and has a maximum load capacity of 2.3 kilograms per arm. Baxter is a built-in sonar arm and camera sensors to detect humans when they enter his space and integrated vision for object detection. Please welcome Baxter. This is the video of how Baxter works.
To be more productive for the company. There's no programming involved. You simply train it by moving the arm, and it's going to mimic that movement. And it's like I said, it's very easy to use. You don't need a bachelor's degree to train it. We have line workers, assembly workers that train Baxter and then become a Baxter expert, so they can maintain and train Baxter and do tasks, and they know how to operate, and they become the go-to in that manufacturing facility when it comes to Baxter questions.
In conclusion, updated robot standards account for these advances for the shared workspace, but require the robot to possess at least one of the following characteristics to work collaboratively: safety, rated monitor stop, cell hand guiding, speed and separation monitoring, and power and force limiting. And finally, collaborative robot can save space and money and increase in flexibility. This concludes my presentation. Have a great evening.